the red light signs.
Okay, so now what we're going to do is transition into a new activity where I'm going to show you how a scientist reads an article. Okay. This is not something that you're used to doing, but this is something that you're going to have to be doing throughout the rest of the class. Because in this class we think and we read and we talk like scientists. So I'm going to show you how this is going to be done. I'm going to show you by thinking out loud. And I want you to pay attention to the kinds of things that I'm saying and to the things that I'm doing and perhaps even writing or acting out.
We're ready.
Okay, perfect. Sounds good. All right. Okay, so this is an article, for example, that you would be given to read for homework. And I'm just going to assume that I'm a student reading this, and I'm going to give you my thoughts out loud. These big words up here, this must be the title, because they're the biggest ones. It says, going deep, and already I stop, because I am wondering why this deep is so big, and different than these other words that I see up here. In fact, it's even like written differently, and I have no idea why it's shaped like this. Why would deep be written that way? This makes me think that this word must be important to the rest of the article. Finishing the title. Going deep with plate tectonics. Oh great, I don't know anything about that. Perfect. Study guide and practice. This must be homework. So it means I'm probably going to have to answer questions about this later. So if there's anything important, I want to mark it right now. Okay, let's start. How do mountains form? Alright, well, mountains. How do mountains form? I don't know. And that's okay to say you don't know. Why do earthquakes happen? Oh geez, I don't think I know this one either. But my guess is, this is my amateur drawing of an earthquake. That's will help me remember. What is a volcano? Okay, I know there's lava in a volcano. And why does it erupt? Okay, erupt. I know this word obviously has to do with the volcano. And I'm pretty sure, just from context clues, that erupt means it explodes. So these three questions: how do mountains form? Why do earthquakes happen? What is a volcano? Why does it erupt? My initial guess is that these probably are going to be answered within the rest of the article. So it's okay. I feel okay that I don't really know the answer. Okay, throughout recorded human history, recorded, this means when history is written down. Written history. There were always questions like these. Questions like these. Oh, these must be the original questions from earlier. Okay. There were always questions like these, trying to understand how or why these events happened. These events, this must be the mountains and the volcano. Okay. Questions such as these, same questions, led to plenty of research from hundreds of scientists, oh boy, over the past century. This is just 100 years. So it sounds like what they're saying is all of our research that we've got on volcanoes and mountains and earthquakes are all within the past 100 years. To research from hundreds of scientists over the past century to find the answers. Okay, so we have answers. These answers were found. Oh, there it is. Perfect. What are they? From the collected facts and evidence, there was a theory to explain it all. The theory of plate tectonics. Oh, here it is. So this plate tectonics is going to explain mountains, earthquakes, volcanoes. Okay. Theory. I've seen this word before in science. I'm pretty sure. A theory. A scientific theory sounds like a scientific guess, maybe? But I don't want to say guess because we use facts and evidence, so I guess a theory is not a guess at all. But I don't want to say it's a scientific law either. Okay, I don't really know what that word means. Maybe it's a rule. I don't know. Okay. The theory of plate tectonics. Okay. Tectonics, volcanoes, mountains. Perfect. We live on a restless Earth. Restless, what does this even mean? Does this mean on Earth is active? Maybe? Okay. In which 7 major and 8 minor tectonic plates move about. Tectonic plates. I don't know what these are yet, but when I think of a plate, I think of like a dinner plate on a table. So maybe that's how I can think of this, as plates on a table being moved around. Tectonic plates move about on top of the asthenosphere. I have no idea what this is. This is a question word. But I know that's in the Earth, and that the plates are on top of it. So it has to be in the Earth. Okay. Okay. On top of the asthenosphere. Whether they're colliding, dividing, or sliding. Colliding, dividing, or sliding. Colliding means to run into each other. Dividing means to move apart. Sliding. Sliding next to each other, maybe. Like I want to slide. Okay. Whether they are colliding, dividing, or sliding, these plates are always in motion. Oh, always. They never stop. Or do they? Okay. Where these plates meet, called plate boundaries, so that makes sense. This is where they meet. Is where most of the earthquakes and volcanoes on Earth happen. Well, there it is. This is my explanation. Most of the earthquakes and volcanoes on Earth happen right around the plate tectonics. Perfect. And this place where they meet called the boundary. That's what I want to do now. Okay. So as you can see, I'm making my thinking very explicit. I'm saying quite painfully. Painstakingly, out loud. A lot of this is going to happen in your heads naturally, but you're going to have to learn to force yourself to pay attention to what it is that you're thinking. So I'm going to give you guys a sheet and a reading assignment, and you're going to take this home and practice it yourselves. You're just going to do exactly what I did. Are there any questions?
No.
Okay, great.